Hello, welcome back. So today we're gonna talk some more, kind of where we left off. We'll review a little bit. I'm sorry that I made that video so long yesterday. I think it was yesterday. I did not realize how long it was until I got to the end. I will do my best to make this one much shorter for you today. And at the end of it, there will be some questions. Some of them will be like questions you might see on the IB test. So what basically for your assignment, I'd like you to just pause the video and try them out as best as you can. I will explain the answers, and then I'll give you like a little video to watch at the end again, just as like an interesting thing. But please email me if I'm going too fast or I'm going too slow or whatever. I'm really sorry I'm not there yet. It's a bummer. And especially with today's lesson, these are all things we will do together in class. Um, they're really fun. They're like different techniques for separating mixtures, as you can see here, right? But today we're just gonna talk about them. So, with that said, let's look at this again. We have this nice little graphic that we had on our slideshow yesterday, and we have all matter, right? All matter can be divided into pure substances or mixtures. We know that elements are just atoms of one kind, right? Like carbon would be a type of element, and then there's compounds, which is combinations of different types of atoms. So like CO2, a carbon and two oxygens. And then today we're going to focus on mixtures. And we know that there are two types, right? Heterogeneous, which means they don't actually like to mix together very well. You can see the difference. Oil and water was our example. And homogeneous, which is like you mix them together, they look uniform. They seemingly have the same properties on a macro scale, like on a big scale. So like salt water, right? Today we're going to talk about how we can separate mixtures and some of the different techniques we use in chemistry to do that. Real quick, before we do, let's review. Classify these as elements, compounds, or mixtures, and then tell me which of these substances would be considered pure. So pause the video real quick, maybe just in your head, or you can do it in your notebook. Answer those two questions, and then I'll talk about it. Give you a second. So, A. A is a compound, right? Has two different elements. This would be a pure substance, all right? There's nothing else in here. B is element, right? Because it's the same atom bonded to itself. This would also be pure because it's just these elements. C would be a mixture, right? Because you have different things put together. So it would not be pure, right? And then D is compounds because we have two different elements bonded together, but it is a pure substance because it's just this set of things over and over again. So, if we want to separate mixtures, there are several techniques we're going to talk about and do in class eventually. The first one is solvation, filtration, and evaporation. And how I'm going to do this is I'll kind of show you these graphics and then I'll basically put all the words I'm saying onto the next slide. So if you're taking notes, which I would suggest, you can just pause and write all the words down when we get to the next slide. So in this technique, we use this if one component is soluble in, let's say, water or some other solvent, and the other is not soluble in water or that solvent. So soluble means it will dissolve, right? The solvent is the thing that dissolves it, right? So water in this case is our solvent. And the solute is the thing that gets dissolved. So we have this mixture, and there are two different things in it, and one of them, the thing that we want, can be dissolved by water, right? So we will add water, we'll add solvent, and that will dissolve the soluble component. So this part is called solvation, right? Add the water, dissolves the green thing, the thing we want, but it doesn't dissolve the other thing. So that's solvation, this part right here. Then we filter the mixture, so that's what's happening right here. Right, we run all of this through this filter, and we separate the soluble and insoluble components. So the insoluble part that didn't dissolve, gets trapped in our filter, while the water or whatever solvent we used flows through with the part that we want. Right, still green. Um, this is called filtration. So solvation, filtration. Then we add heat to our water, right? And that makes the water evaporate. And so we heat up the water, it evaporates, and the dry component can then be collected, right? Um, so this part is the evaporation part. So solvation, filtration, evaporation. Here's all the words I was saying, basically. And here's a note. We're going to talk about drying to constant mass. I have this note in there a couple times. Once we actually are doing this, I will show you how to make sure we dry to constant mass. But this is a skill we'll need to learn for the IB stuff as well, and just a general chemistry skill. It just has to do with measuring in the right quantities. But here's all the words. So solvation, filtration, evaporation, right? Technique number 2. Our second technique is called paper chromatography. This one is cool, also kind of pretty. We'll do this in class as well once I get there. But basically the idea for this one, it's a technique that is used when the components of the mixture have different attractions to the mobile and stationary phase due to their intermolecular forces. That was a lot of words. So that means like we have a mixture and it's on, let's call this paper, right? Paper chromatography. So we put a dot of our mixture, or many dots, onto the paper. So there are 2 different things in our mixture, at least, maybe more. And those different things have different levels of attraction to the paper and to the water, right? So the paper is the stationary phase, it doesn't move. And the water is the mobile phase. It will move up the paper. The water is attracted to the paper. That's why it's moving up it. And as it hits our mixture, it will begin to take parts of the mixture with it, because some of the mixture will be more attracted to the water than it is to the paper. So it's really cool when you do it. You see all these different colors. I can't remember if I put an actual picture of it in this slideshow, but we'll do it in class. You literally just dip it in there, leave it for a while, and then you see how it separates. And it is used to identify components in a mixture and not to collect them. So it's to see like how they're different, right? And in biology, there is lots of types of chromatography that you might use. Yeah. So there's some like technical values we'll get into eventually. We're not going to worry about it right now. But this is basically what I'm saying. Mobile phase is the water, that's what's moving. The stationary phase is the chromatography paper. And then the solvent front, that would be the water. The front of the water, like its edge. And so, yeah, there you go. And IMF's intermolecular forces. I'm guessing you've heard of those if you had chemistry classes before that, but that's basically the forces that are governing the interaction between the different molecules themselves. So like, how is the water molecule attracted to the salt molecule or something like that. Our next technique you have probably heard of. It's called distillation. This is also kind of a fun one. We'll do a demo of this. And this technique is used to separate a mixture of liquids with different boiling points. So for instance, water boils at 100 degrees Celsius, but ethanol boils at a different temperature. So we collect the liquids, beginning with the lowest boiling point first, and then gradually increase the temperature. So you could have a bunch of liquids. You could have like a big mixture of liquids, and you could separate out each of them using this technique. So like, let's say we have a big mixture of liquids. We add heat, right? The one with the lowest boiling point will begin to turn into a gas, right? And it will travel upwards until it gets to here. And in this tube, there is this thing which is cooling the tube down, right? There's cold water coming in and out. So this part of the tube is cold and this part is hot. So those gas particles travel up, they go into the cold part of the tube, which will cool them down enough that they become a liquid again. So it separates out the higher boiling point liquids from the lower boiling point liquids. Um, and these contraptions can get complicated, but this is the most basic idea, right? You're just adding heat. The lower boiling point things are going up through the tube and then collecting in this uh, beaker over here. Here's all the words. This is a video which I will post in ManageBack that you can watch. You don't have to, but it is interesting. It's the fractal distillation of crude oil. So this is like an industrial use of a distillation technique, and obviously lots of oil gets produced. So if you are interested in that process, you can watch that. And it's just kind of shows you how they do this on an industrial level. Our next technique is called recrystallization. And this one is interesting. This technique is used when the desired product is less soluble in a solvent than the impurities. So right here, the desired product is red, the impurities are yellow. We're saying that our desired product, the thing we want, is less soluble or is harder to dissolve in our solvent, like let's say it's water. It's harder to dissolve in water than the impurities. That's when we use this technique. So for this one, we add a minimum amount of hot solvent. So maybe it's hot water that we add. This will dissolve the impurities easily because they want to dissolve and only barely dissolve the desired product. So everything will get dissolved, but the desired product is close to its saturation point, which means it wants to come out of solution, right? It wants to recrystallize. So this produces a hot saturated solution. That's what we have right here, right? As this solution cools, so we let it cool down, the solubility of the desired product decreases. As it cools down, it will come out of solution, right? The colder it gets, the less soluble it is. And it will crystallize, so we'll get crystals of our desired product. It'll come back out. But the other impurities stay dissolved because they dissolve more easily in our water or solvent. And so we can collect these crystals by filtration, right? Just like in that first technique. We'll pour that water or whatever that solvent is through the filter, collect our crystals, and the impurities will be left in the water. Here's all the words. There you go. And then, yeah, here's the dried to constant mass, which we'll talk about when we're actually doing it. So, those are the 4 techniques. I would write these steps down. You do need to know these for the IB test. They will ask you questions about technical lab things. You should know how and why we use these techniques, and we will do at least most of these in class at some point. That's the fun part. Sorry I can't be there today to do that with you, but we will do it eventually.